Solving one-step equations, part 2. So we finished the last video with step 3, which is get the variable by itself by doing the inverse or opposite of the operation with the variable. So here, when we have x minus 223, which is equal to 721, since here is my variable, the operation of subtraction, how to undo a minus 222 or 223 is we need to add 223. So here I'm going to add 223. And if you think about it on a number line, remember that's really a negative 223. And to get back to 0, I would have to go to the right or add 223 spaces. So now I have x minus 0, which is really the equivalent of having just plain x. Now, step 4. Whatever we do to one side, we must do to the other. Otherwise, our scale will be unbalanced. Right now, this one would be leaning like this because we've taken things out of here, but we haven't done the same thing to the other side. So step 4, whatever you do to one side, you must do to the other. And it must be the exact same thing. So if I subtracted 223, then I need to subtract 223 over here. Since I added 223, I need to add 223 over here. So now on this side, I have 1 plus 3, which equals 4, 3 plus 2, which equals 5, and 7 plus 2, which equals 9. So now, since all I have on the left side of my balance is x, and all I have on the right side of my balance is 954, ipso facto, x must equal 954. Step 5 is a crucial step as well. Step 5 is check your answer. The way we recheck is replace the variable with our new value and solve. So when we had the initial x minus 223 equals 721, we now place 954 because that's the value of x. 954 minus 223, and we should get, and I like to do it up and down here, so we have 223, 4 minus 3 is 1, 5 minus 2 is 3, 9 minus 2 is 7. Did I do it again? 5, 7, 8, 9, 223. 4 minus 3 is 1, 5 minus 2 is 3, 9 minus 2 is 7, but I get 731 instead of 721, so where is my mistake? Oh, I see it. Back up here, I have 223 here, but I have 233 on this side. That's why it's not working, because I have to do the exact same thing on both sides. So here, I need to change this to 223. This is another reason this line is good, so you can see the mirror image to make sure you do the exact same thing here that you do here. So instead of 5, that would be 4. So if I come down here, now I need to have 4 here, 944, which then makes this 4 minus 2, 2. Now, my answer equals 721. Do not shortcut this checking piece because you must check to find errors that I often see, silly errors like misprinting what you have from one side to the other. If you do this check step and actually go back and look to see what errors you could have made, it will help you immensely find some of those silly mistakes. Don't shortcut the checking. Okay, now that we know that addition can be undone by subtraction and subtraction can be undone by addition, what do you conject we could do to undo multiplication? If you said division, good job. Let's try a division problem or a multiplication problem on our next page. Let's pretend we had the problem 8x is equal to 28. Originally, this looks pretty easy, and we might possibly be able to do the cover-up method. However, once I cover up the x and ask myself, what times 8 would equal 28? No basic facts come to mind. Therefore, my answer, I can infer, must be a decimal. So we're going to have to go through our steps and solve this using inverse operations. Step 1, make sure you separate your problem into two sides, the left side of the balance scale and the right side of the balance scale. Next, locate the variable. Here's the variable. Now I need to ask myself, how do I get that variable by itself? Well, right now, step 3, since it is being multiplied by 8, to undo that, I need to divide by 8, because the inverse operation, or the opposite of multiplying by 8, is dividing by 8. So on this side, I divide by 8, and if you think about it, 8 divided by 8 would equal 1. So here I now have 1x, which we should know from our last unit, that once you have 1x, we have the identity property of multiplication. We know that anything times 1 is going to be itself. So any x times 1 is just simply going to equal x. So this is the same as just having x in our pan. If you don't understand that, it's a little higher level thinking. Just trust that mathematicians are always looking for patterns. So since we know addition and subtraction are inverses, we also know multiplication and division are inverses, or opposites of each other, so they are able to undo each other. Step 4, whatever I've done to one side, I must do to the other side. The exact same thing. So if I divided by 8 here, I need to divide by 8 over here. And I hope you're writing this in your notebook along with me. So now all I need to ask myself is, what is 28 divided by 8? Well, that's not a basic fact, so I need to do my work over here in my workspace. And I ask myself, how many groups of 8 can I make out of 28? So in this case, it would be 3. So 3 times 8 is 24. When I subtract, I get 4. Now, x equaling 3 remainder 4 is not going to help me. I could do x equals 3 and 4/8 as a fraction, but I really prefer decimals. So at this point, I know I can add a decimal to 28, and then I can add zeros behind the decimal until the cows come home. So I can keep adding zeros until I get an exact answer. Hopefully we won't have to add too many. So I add a 0, bring it down, and now I have 40 pieces. How many groups of 8 can I make out of 40? I can make 5. And don't forget, where does that decimal go? Straight up, now tell me. That is where the decimal goes. Oh, oh, oh. So 5 times 8 is 40. 40 minus 40. I am done. I have nothing left over. I have 3 and 5/10, which we know is the same as 3 1/2. And if we look at that as 3 and 4/8 that we originally had, we know 4/8 is 1/2, hopefully. So all of these are equivalent answers and acceptable answers for what x equals. So x equals 3.5. And step 5, super important, last but definitely not least step, is to check. If x equals 3.5, will I get 28? So I replug it into my original problem, 8 times 3.5, and I see does it equal 28. So now I need to multiply decimals. However, am I going to line up the decimals? No. What's the exception to the rule? When you multiply, you fool. So I am just going to set this up as if it were 35 times 8. 8 times 5, 0. Carry the 4. 8 times 3 is 24, plus 4 more, 28. How do I figure out where the decimal goes? However many places are in my question equals how many places are in my answer. So 28.0 is exactly the same as 28 here. So it does check that if x equals 3.5 and we multiplied it by 8, it would indeed equal 28. Let's try another one, and I'm going to walk you through it verbally while you do it on your paper, and then I want you to check to see if you have the same thing that I have. The problem is going to be x divided by 2 equals 3.77. So I tried my cover-up method because that would be the easiest. However, I don't know what divided by 2 would end up being 3.77 because it's not a basic fact. So I'm going to have to use my inverse operation. So the first thing I need you to do is to divide your problem into 2 sections. I'm going to pull my paper away so you can do it on your own. Divide your problem into 2 sections. Locate the variable. Identify what's being done to the variable. In this case, x is being divided by 2. So I need to apply the inverse operation, which will be, since it's a divided by 2, I need to undo that by multiplying by 2. So I'm going to multiply by 2 on one side. Step 4, whatever I do to one side, I need to do the exact same thing to the other side. So I need to multiply the right side by 2. I'll give you some time to do that. Okay. Once you have that multiplied on both sides, our last step, not last but not least, is definitely checking it. So plug your answer for x, your value for x, back into your problem and divide it by 2 to see if you get 3.77. All right. If you are not done with your problem, go ahead and push pause until you finish the problem. Otherwise, see if yours looks like mine. Divided the problem into 2 sections, located my x. It was divided by 2, so I multiplied by 2 on both sides. I did not line up the decimals because the exception to the rule is when you multiply, you fool. So I multiplied it as if it was 377 times 2 and got 754. But 2 decimal places in my question equals 2 decimal places in my answer. When I checked it over here, it came out to be exactly the 3.77 I had started out with. So I know that I get a check plus for doing my work today. Now, for those of you that wonder why it undoes itself here, if you think about this, this is really 2 times x over 2. And when we multiply, we have to have fractions times fractions. So this is really going to be 2 over 1. So then I have numerator times numerator, which is going to equal